Right now, you are looking at a neural network that is learning my small jumping game. So, today we are going to go through the journey of how to make a neural network learn a game. But before we start with the game, we need to know what a neural network even is. Well, in its simplest form, a neural network is built in three parts: the input layer, the hidden layer, and the output layer. Note that there can be multiple hidden layers. The things in each layer are called neurons and the connections are called weights, which set the strength of each node. When using a neural network, data is passed into the input nodes and the results is stored in the output nodes. The value of the next layer's nodes is the sum of all of the previous layer's nodes, multiplied by their connected weights. The neurons also have a bias weight, which is always 1, but we're not talking about that today. You just need to know that the weights are what makes the network do what you want it to do. So let's move on to how this neural network will actually learn. If you know a bit about neural networks, you might think it will learn through backpropagation. But for this type of network, we won't be using it because it would involve giving it the correct answers, which would be too hard to program. Instead, we will be using a better algorithm called the evolutionary genetic algorithm. Or as I like to call it, survival of the fittest. For this program, the neural network will run multiple times, each time getting a score of how well it's doing. When the network finishes running, a new network model is created using the highest scores weights at random. A weight has a chance of being completely random, simulating mutations in evolution. This will keep the program from making all of the neural networks become stupid. So now that we got the basics, let's move on to the actual program. This is just a simple jumping game in which you have to do a big jump over big blocks, and little jumps over small blocks which have a top block. Successfully jumping over a block gives you a point, while hitting one kills you instantly. 100 bots will run through this game over and over again, the two highest scoring networks getting merged with the genetic algorithm. Then the next 100 bots are given this new neural network with a chance of mutation in each. I also found that making the last 5 networks completely random helps out with the randomness. The neural network of the bots looks like this. The 3 inputs are the horizontal distance between the player and the block, the height of the player, and the height of the block. The output is either a high jump or a low jump. The output has to be greater than 0.9 for it to activate one of these jumps. So knowing these things, let's see how well the bots do in the simulation. After getting to generation 29, the bot was able to keep on going through the game without dying. The weights of its network look like this. I've saved a few of the best weights I've gotten so far. These include Best, Best 1, Hopper, Outbreed, and Punk. Hopper just hops the entire time. Punk is a punk who keeps no clipping for some reason. Outbreed doesn't really work, Best doesn't always work, and Best 1 is perfect. So now you've gotten a glimpse of how an evolutionary AI works. It somewhat ended up doing what I was looking for, so it was a fun little project. Thanks for watching, and I'll see you guys later.